Hello everyone. Today is December 16. That means it's time to open a new problem from our LeetCode for our Coding Advent Calendar. Today's problem is about queues and stacks. These two are very powerful data structures since they allow you to read and write values in a constant time with some limitations. Let's see what the problem is about. Here is a problem for today. Implement queue using stacks. Implement the first in, first out queue using only two stacks. The implemented queue should support all the functions of a normal queue: push, pick, pop, and empty. Implement the myQueue class. Here is it. Void push integer x pushes element x to the back of the queue. Int pop removes the element from the front of the queue and returns it. Int pick returns the element at the front of the queue. Boolean empty returns true if queue is empty, otherwise false. Notes: you must use only standard operations on stack, which means only push to pop, pick pop from top, size, and is empty operations are valid. Depending on your language, the stack might not be supported natively. You may, okay, we don't need this because we use C# and it supports stack as we need. So, okay, what do we need to do? Generally, we have two types of, there are two similar data structures, queues and stacks. The only difference between them is first one is first in, first out, which is FIFO, and the second one is first in, last out, which is FILO. So when we add something, let's imagine this is our queue. One, let's do this like this. I will create a comment here. Okay, I put 1 and then I put 2 on top, so 1 goes down. Then I put 3 on top, 3 goes down. Then I put 4 on top. And if I read it, if it's queue, I read it in same order. I read 1 first, then 2, then 3, then 4. If I use stack, it's a different way. 1, then I put 2, then I put 3. If I need to read 1, I will read 3. If I need to add 1, I will add 4 on top of 2, then I can add 5. And if I need 4 reads, I will read 5, then 4, then 2, then 1. So our problem states that we need to implement queue using two stacks. How are we going to do this? So first let's define these stacks, right? st1 st2, and here we will arrange them, right? We will create new instances. Okay, now we need to create push operation. And push operation will do the following. We have the stack 1. Let's try to again draw it. So we have st1 and we have st2. We put something on top of st1. 1, 2, 3. Then we need to read it, but we need to read 1 first, then 2, then 3. How can we do this? We cannot take it directly from this stack. So what are we going to do? We will take this 3 and move it to stack 2, like this. Okay, it will be moved here and it will fall to stack 2. Then I will move 2 to stack 2. Then I will read this one and put 1 on stack 2. Then I can read this into like I read a queue, right? So we changed the order. If I read only one value, so 2 and 3 remains on stack 2, and I can put more values here on stack 1, like 4, 5, 6. Right? Now, when I need to continue read, I continue read from stack 2, which means the next value is 2, then 3. When stack 2 is empty, in order to read, I need to check stack 1. If there is something on it, I will repeat this process again. I will put 6 on stack 2. Then I will put 5 on stack 2. I will read everything from stack 1. And then I will put 4 on stack 2 until stack 1 is empty. Then I can read again, and I can also push values on stack 1 again. So what do we know right now? We know that we always push on stack 1. That's it, we implemented our push operation. If we need to pop something, we will need to do this. If st2 count equal to 0, so this is empty, we need to check this one. And we will do this while st1 count more than 0, we will push value from stack 1 to stack 2. That's it, and when we're done, we can read something from stack 2. That's it. And for pick operation, we need to do the same thing, but instead of pop, we will pick. And for empty, if our queue is empty, that means we don't have anything on stack 1 and stack 2. So we will just return st1 count equal to 0 and st2 count equal to 0. That's it. Let's try. Okay, yeah, count. Okay, done. Our case is valid. You can check with any test case you want. And I will submit. And it's done. Our solution beats 98% of all solutions. So, what is the time complexity of our solution? time complexity is big O of n, which is depending on how many operations we want. This is our it is actually not quite clear what exactly we need to estimate. So each individual operation here, push, pop, and pick and count, they are big O of 1. They run in constant time. The only problem here is when we do pop and pick, we need to read values from one stack and put it into other stack. That means push is big O of 1, pop is big O of n, pick is big O of n, and empty is big O of 1. And from memory perspective, it is big O of n because we need to store values until we pop them, these values. So if we push, 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 and push, we need to store this value somewhere. So like in usual queue or in stack itself. That's it. That's a very simple problem, but nevertheless it is a very popular question on interviews in companies like Amazon. Okay, no, it will show us all questions from Amazon. So 5 times these questions was asked by Amazon in interviews, and these interviewers reported this question here. From 6 months to 1 year, there are more companies asking this question. This is a very popular one, and I hope you find it easy. You just need to know the trick. I hope you enjoyed today's video. If so, then press like and subscribe. Or even better, write a comment. Tell me whether you're able to solve this problem yourself. Of course you do. See you tomorrow.